In the last part of this lecture, let's take a look at quantum adjustment. Now, before we explicitly go into quantum adjustment, let's first take a look at what we call as a Siegel's paradox. So essentially it's stated this way. Let's say you have two countries and you have a currency X and currency Y. And you have a risk-free rate in each country. So for country X, you will have risk-free rate Rx, and for country Y, you have Ry. Okay, so you look at a risk-neutral process of exchange rate. So let's say you define the exchange rate as units of currency Y per unit of currency X. Okay, now when you define your exchange rate this way, you can write down a risk-neutral process where the change of exchange rate is related to what the deterministic part is really the change, the difference in interest rate, right? And dt, and you have a random term here. Okay, this is all very sensible process. Now, if you look at the process for exchange rate expressed in a different way, so instead of units of currency Y per units of currency X, you're looking at the exchange rate expressed as units of currency X per unit of currency Y, which is 1 over S. Then if you look at D 1 over S, now by Ito's lemma, and you take it that this as the original process S, the function 1 over S will follow this process here, okay? Well, this is a little strange because people would have thought, well, the 1 over S is just, you know, the rate of interest rate difference, which is just switching Ry minus Rx to Rx minus Ry. And here is 1 over S and sigma as 1 over S here. And why there's this term here, which is sigma S square, right? People would have expected for symmetry, if you have something like this for one currency, but exchange rate expressed in one way, if you express your exchange rate the other way, you should have this thing here. Instead, Ito's lemma tells you that you have an extra term here, which is a little troublesome. That's why it's called a paradox here. And in fact, we'll see that there is no paradox because this extra term is related to quantum adjustment, which was the one we're gonna talk about in this last part of the lecture.